Hi, and welcome. In this video, I'm going to go through how to solve some inelastic collision problems. So here in this first problem, we have a red cart that's moving with some velocity towards a green cart, which is staying stationary. Okay, so the mass of the cart on the left is 1,600 kilograms. The velocity of the cart as it moves toward the green cart is 12 meters per second, and the mass of the green cart is 3,200 kilograms. So we're assuming that since it's an inelastic collision, the red cart hits the green cart, and they stick together, and then they continue to move to the right together as one unit. That is what we're trying to solve for. We're trying to figure out how fast they move when they combine into one unit. Okay, so we're going to think about momentum in order to solve this problem, to figure out how fast they move when they combine after the collision. So first, let's think about before the collision. So we need to know what's going on with momentum of each cart before the collision. So we'll start with the red cart. We know that momentum, or P, is equal to the mass times velocity. In this case, we know that the mass of the red cart is 1,600 kilograms, and we know that the velocity is 12 meters per second. When we crunch those numbers, we get a momentum of 19,200 kilogram meters per second. So that is the initial momentum of the red cart. Okay, so now let's talk about the green cart. So the green cart, again, same equation for momentum. In this case, the mass is 3,200 kilograms, and the velocity is actually 0 because it starts initially at rest. So since the green cart is at rest, we should know intuitively that it therefore has 0 momentum because it's not moving. So that's 0 kilogram meters per second. Excellent. So now the total momentum of the whole system between the two, well, that's kind of simple. In this case, it's 19,200 since the red cart has momentum, but the green cart does not. All right, so now we have the total momentum of the system before the collision. We next need to look at after. But in order to get to after, we have to remember the conservation of momentum. That tells us that the total momentum before the collision is equal to the total momentum after the collision. So we can take our 19,200 in purple there and actually just bring it right up to the after section. And then we're going to manipulate the momentum equation, P equals mv. We're going to solve for v in this case, or v total. That's actually what we're looking for. That's the velocity of them when they combine and move together at the end. So we have the final velocity, or total velocity, is equal to the total momentum of the system after the collision, divided by the total mass of those two carts combined. Okay, so in this case, the total momentum of the system after the collision, that is 19,200. And the mass total is that 1,600 kilograms from the red cart combined with the 3,200 kilograms of the green cart. So when we crunch those numbers, we got a final velocity, or a total velocity, of 4 meters per second. So we figured out how much momentum the system had before the collision. There was some momentum in that red cart because it was moving, but there was no momentum in the green cart. We know that that initial, or total momentum before the collision, is equal to the total momentum after the collision. So we use that to solve for the final velocity, or total velocity, of the two after they combine in this inelastic collision. So they're moving forward together. All right, so let's move on to one more example. We're actually going to keep the same exact problem with this red cart coming in with some velocity and hitting a green cart. They're going to combine in that same inelastic collision and continue on together. However, in this problem, we know the mass of the red cart is 1,200 kilograms, and we know that it starts with a velocity of 14 meters per second. However, we do not know the mass of that green cart. So that's what we're going to need to solve for in this problem. Since we don't know that, we actually are given the total velocity at the end after they interlock together. That velocity is 8 meters per second. So again, let's take a look at momentums. We'll start with before. So initially, the red cart has some momentum because it's moving. That's the mass times velocity, or 1,200 kilograms times 14 meters per second. Put that in the calculator, and we get that the momentum of the red cart is 16,800 kilogram meters per second. And then that green cart, so we have mass times velocity once again. We don't know the mass in this case. However, we know that it's stationary, or it's at rest, so its velocity is 0. Since the velocity is 0, we know that it does not have any momentum at all. Even though we don't know the mass, we can just say that the momentum is 0. Because it's stationary, it's at rest. So that means that the total momentum at the beginning, or before the collision, is equal to 16,800 kilogram meters per second. Just like the last problem, we're going to use that conservation of momentum to help us out, noting that the momentum before the collision is equal to the momentum after the collision. So we can take that 16,800 and move it up to the after box here. In this case, we're going to once again manipulate the momentum equation. However, this time instead of solving for velocity, we're solving for mass. So the total mass between the two combined is equal to the momentum of them combined divided by the velocity of them when they move together as one unit. However, we're not solving necessarily for the total mass. We're actually solving for one of the masses in particular. We're solving for that green mass, or the mass is notated as 2. So we know that the total mass is mass 1, or red, plus mass 2, or the green one. And we can plug that back in or substitute it into the equation. So we have the two masses combined is equal to the total momentum divided by the total velocity. We then want the second mass, or the green mass, on its own. So we subtract the first mass over to the other side. So we get that the second mass, or the green cart, is equal to the total momentum divided by the total velocity minus the mass of the red cart. Okay, so now we're just ready to plug in our numbers. So we do 16,800 divided by 8, which is the final velocity or total velocity of them once they're together. And we subtract out the 1,200, which is the mass of the red cart. And we get that the mass of the green cart is equal to 900 kilograms. So in this case, we were given what the velocity was after they combined, or after they inelastically collided, but we didn't know one of the masses. So instead of solving for velocity like we did in the last problem, we solved for the mass of one of the two carts. Okay, so these were 2 example problems on inelastic collisions. That's going to be it for today. Thanks for watching.